Let's go ahead and solve this trig function. 2 sine squared of x plus 3 cosine of x minus 3 equals 0. And the approach that we're going to take on a problem when we're trying to solve, and we have 2 different trig functions, is we want to rewrite it so that our entire function has only one trig function. So as you can see here, it's in sine and cosine. And so what we want to do here is we want to leave this in cosine right here, and I'm going to change sine squared. I'm going to use my Pythagorean identity and just use 1 minus cosine squared right there. All right, so let's go ahead and do that. So 2 times I'm going to replace this guy right here with 1 minus e. All right, try that again. 1 minus cosine squared of x plus 3 cosine of x minus 3 equals 0. All right, cool. I'm going to go ahead and distribute the 2. So 2 minus 2 cosine squared of x plus 3 cosine of x minus 3 equals 0. And I'm going to do 2 things in this next move here. I'm going to go ahead and do 2 minus 3, okay, and that's just going to be negative 1. But then I'm going to multiply both sides by negative 1. And the reason for that is I want to make my leading coefficient positive, because I know that I'm going to factor this. And factoring with the leading coefficient being positive is much easier and nicer than when it's negative. So this negative 2 cosine squared will become a positive 2 cosine squared of x. This positive 3 will become a negative 3 cosine of x. And 2 minus 3 is negative 1, but then I multiply that by a positive, so positive 1 equals 0. Okay, so now this trigonometric function is in the form of a quadratic, meaning if I replaced my cosine squared, my cosine of x with x. So if I let x equal cosine of x, then that means that this would be now 2x squared minus 3x plus 1 equals 0. Right? I just replaced the cosines with just x. And that's kind of neat, because now this becomes a quadratic that we've factored all day long in algebra 2 and in algebra 1. So now let's factor this, and then we'll replace all of our x's with cosine when we're done. And again, you don't need to do this whole step right here. If you can straight go from here and then factor, that's cool. I just kind of do that just because we're used to this, and it may get rid of just a little bit of the clutter, but it's up to you how you view it. So I know when I multiply my 2 binomials, my first terms must give me 2x squared, so 2x and x. My last terms must give me 1, so that's only 1 and 1. And if I want my middle term to be negative, well, watch this. If I multiply these guys, that's 1x, that's 2x. So I want those to be a negative 2x and a negative 1x. So there we have it. And this is equals 0. So now that it's factored, let's replace all the x values with cosine of x. So that's 2 cosine of x minus 1. And that's cosine of x minus 1 equals 0. Set each term equal to 0 and solve. So that means that this would be cosine of x equals a half. And this one right here would be cosine of x equals 1. All right, this is just a matter of you now just knowing the unit circle and where on the unit circle do you get 1/2. And that will happen at pi over 3. And let's see, what else? It's going to be at a pi or something. Oh, 5 pi over 3. And then over here, the only time that cosine is 1 is at 0. So x equals 0. Okay, so since we weren't given any restrictions, we have to give all the solutions, the infinite solutions. So if you're at pi over 3, you can go around again and around again. So I'm going to plus 2 pi n, where n is within the integers. And the reason why I chose 2 pi is because that is a period of cosine. Okay, same thing right here, plus 2 pi n, where n is within the integers. And right here again, you can put You don't have to put 0 plus, but we'll just put 0 plus 2 pi n, where n is within the integers. And those would be our 3 solutions for this quadratic function.